A gigantic, history-making space rock is about to swing by our planet again, and this time, you actually have a chance to see it with your own eyes. For 33 Eros, the very first near-Earth asteroid ever identified by astronomers, is making a relatively close pass by Earth on Sunday, November 30, 2025, gliding by at a distance of about 60 million kilometers, roughly 37.2 million miles. That works out to around 0 for astronomical units, meaning it will be about 40% of the distance between Earth and the Sun, comfortably safe, but still near enough for sky watchers to get a rewarding view. And this is the part most people miss, even though that sounds incredibly far. In cosmic terms it is close enough that a simple, beginner-friendly telescope can reveal this visitor from deep space. Eros will remain visible for several weeks around this time, as long as you have a reasonably capable backyard telescope. Something in the range of about 60 mm in aperture is enough for many observers under decent skies. Because it is a relatively large asteroid, measuring roughly 34 by 11 by 11 kilometers, about 21 by 6.8 by 6.8 miles, it reflects enough sunlight to appear as a bright point of light when viewed through such equipment. Think of it as spotting a tiny, fast-moving dot of light among the stars rather than a detailed, resolved object. For an extra visual treat, the asteroid will sweep just a few degrees away from the bright central region of the Andromeda Galaxy, the nearest large galaxy to the Milky Way. That means if you know how to find Andromeda in the sky, you can use it as a helpful guidepost to track down Eros. It is a rare alignment, a near-Earth asteroid passing close to the glowing core of an entirely different galaxy in the same field of view. But here is where it gets controversial for some space enthusiasts. While many people focus on more famous targets like the Moon, Saturn's rings, or bright nebulae, quiet encounters like this one with Eros are scientifically rich and historically meaningful, yet often overlooked by casual observers. If you cannot observe Eros directly from your location, due to poor weather, light pollution, or lack of equipment, you still have excellent options. The Virtual Telescope Project, in collaboration with the Asteroid Foundation, plans to stream the Flyby live on November 30 at 8 p.m. Universal Time Coordinated, 3 p.m. Eastern Standard Time, via their website. During the live stream, you can expect commentary, real-time telescope views, and explanations aimed at both enthusiasts and newcomers, making it a great way to participate without needing to step outside at all. Eros itself has a long and storied relationship with humanity. Astronomers first documented this asteroid in 1898, making it the earliest known example of what is now called a near-Earth asteroid, a class of objects whose orbits bring them relatively close to our planet compared to most main belt asteroids. Historically, credit for the discovery usually goes to German astronomer Gustav Witt and his assistant Felix Link at the Uranier Observatory in Berlin, because Witt was the first to formally publish the finding of this new body. However, and this is a detail that sometimes sparks debate in astronomy circles, Eros was also identified independently around the same time by Auguste Charlois at the Nice Observatory in France. This raises an interesting question: when discoveries happen almost simultaneously in different places, how should recognition be shared? Some people feel that the story of Eros is a perfect example of how scientific credit can be more complex than a single name on a page. Since that initial discovery, humanity's connection with Eros has grown deeper through direct exploration. In 1998, NASA launched the Near-Earth Asteroid Rendezvous Shoemaker spacecraft with the specific goal of visiting Eros. The probe eventually approached to within about 3,800 kilometers, 2,400 miles, of the asteroid, using its suite of instruments to study the object's size, irregular shape, rotation, and other physical properties. On February 14, 2000, Valentine's Day, fittingly enough for an asteroid named after the Greek god of love, the spacecraft began orbiting Eros. This milestone made Eros the first asteroid ever to be examined in detail from its own orbit, rather than just from a flyby. Over the following months, NEAR Shoemaker built up a detailed picture of Eros's surface, its craters, boulders, and overall structure, giving scientists unprecedented insight into the nature of rocky bodies that cross Earth's path. By 2001, the mission team attempted something ambitious, guiding the spacecraft all the way down onto the asteroid's surface. The touchdown was intended more as a controlled impact to conclude the mission than a long-term landing, but what happened next surprised almost everyone. Instead of failing upon contact, the probe survived the descent, settled on the surface, and remained functional. Because the spacecraft's instruments kept working, mission controllers were able to take advantage of this unexpected success. NEAR Shoemaker carried out the first gamma-ray measurements directly from the surface of a body other than Earth, a significant scientific achievement. Gamma-ray experiments help scientists determine the composition of the material beneath the surface, so this result showed that delicate instruments can be placed directly on an asteroid and still provide high-quality data. This has big implications for the future. If a probe can safely land on and study a small, airless world like Eros, then similar missions could one day explore other near-Earth asteroids, perhaps even as a precursor to mining resources or testing planetary defense technologies. Some people see this as an exciting foundation for future asteroid utilization, while others worry it might open the door to commercial exploitation of space before international rules are fully in place. So, over the next few weeks, if you manage to track down 433 Eros in the night sky, you are not just looking at another moving point of light. You are seeing a scientifically important object that helped pioneer our understanding of near-Earth asteroids and proved that landing on these small worlds is possible. In a way, giving it a quick nod through your eyepiece is like saying thank you for all the knowledge it has already given, and the future missions it continues to inspire. Now it is your turn. Do you think events like this flyby deserve more public attention than they get, or are people right to focus mainly on more dramatic sights like eclipses and meteor showers? And when two astronomers discover the same object independently, how do you believe credit should be shared? Share your thoughts, agree, disagree, or bring your own hot take in the comments.